day everyone, I'm Fevie Lyn Vargas and I'm going to discuss to you all about data transmission. So data transmission is the transfer of data from point to point, often represented as electromagnetic signal over a physical point-to-point or point-to-multipoint communication channel. A communication channel refers to the medium used to convey information from a sender or transmitter to a receiver, and it can use fully or partially the medium. Example of channels such as copper wires, optical fibers, or wireless communication channels. Taxonomy of transmission modes. So transmission modes has parallel transmission and serial transmission. So when you say serial transmission, it has also its modes. So we have asynchronous, synchronous, isosynchronous. So a transmission mode is the manner in which data is sent over the underlying medium. Transmission modes can be divided into two fundamental categories, such as serial, parallel. When you say serial, one bit is sent at a time. When you say parallel, multiple bits are sent at the same time. So parallel transmission, it has 8 bits. Each bit uses a separate wire. To transfer data or a parallel link, a separate line is used as a clock signal. This serves to inform the receiver when data is available. In addition, another line may be used by the receiver to inform the sender from the data has been used and is ready for next data. So when you say transmission, it has also a serial transmission. Serial transmission has 8 bits. Each bit is sent over a single wire, and one after the other. Usually no signal lines are used to convey clock or timing information. There are 2 types of serial transmission, essentially having to do with how the clock is embedded in the serial data, which is asynchronous serial transmission and asynchronous serial transmission. If no clock information was sent, the receiver would misinterpret the arriving data due to bits being lost going too slow. Parallel transmission is obviously faster, in that all bits are sent to data in the same time, whereas serial transmission is slower because only one bit can be sent at a time. Parallel transmission is very costly for anything except short links. So it has the sender, media, and the receiver. When you say asynchronous transmission, because no signal lines are used to convey clock or timing in information, this method groups data information together into a sequence of bits, 5 to 8, then prefixes them with the start bit and the stop bit. It is the method most widely used for PC or simple terminal serial communications. In asynchronous serial communication, the electrical interface is held in the marked position between characters. The start of transmission of a character is signaled by the drop in a signal level to the space level. At this point, the receiver starts its clock. After 1 bit time, the start bit come 8 bits of true data followed by 1 or more stop bits at the marked level. The receiver tries to sample the signal in the middle of each time. The byte will be read correctly if the line is in the intended state when the last stop bit is read. Thus, the transmitter and receiver only have approximately the same clock rate. A little arithmetic will show that for a 10-bit sequence, the last bit will be interpreted correctly even if the sender and receiver clocks differ by as much as 5%. It is relatively simple and therefore inexpensive. However, it has a high overhead and that each byte carries at least 2 bits, at 20% of line bandwidth. So, it is the synchronous character of 8 data bits, 1 stop bit. So, synchronous transmission. The PS/2 mouse and the keyboard implement a bidirectional synchronous serial protocol. The bus is idle when both lines are high, open collector. This is the only state where the keyboard or mouse is allowed to begin transmitting data. The host and the ultimate control over the bus and may inhibit communication at any time by pulling the clock line low. The device or slave always generates the clock signal. If the host wants to send data, it must first inhibit communication from the device pulling clock low. The host deposits data low, releases clock. This is the request to send state and signals to the device to start generating clock pulses. So, this is the summary bus states. When you say data is equals to high and clock is equals to high at the state. When you say data equals to high and clock is equals to low, communication inhibited. When you say data is equals to low and clock is equals to high, it means it host requests to send. So data is transmitted 1 byte at a time. 1 start bit, this is always 0. 8 data bits, less significant bit first. A parity bit, add parity. The number of ones in the data bits plus the parity of always add up to an odd number. This is the use for error detection. 1 stop bit, this is always 1. Acknowledge bit, host to device communication only. So data communication terminology. It has channel, baud rate, bits per second, bandwidth. When you say channel, a channel is a portion of the communications medium allocated to the sender and receiver for conveying information between them. The communications medium is often subdivided into the number of separate paths, each which is used by the sender and receiver for communication purposes. When you say baud rate, is the same as a symbol rate and is a measure of a number of line changes which occur every second. So each symbol can represent or convey one binary encoded signal or several bits of data. For a binary signal of 20, it is equivalent to 20 baud. So there are 20 changes per second. So bits per second. This is expression of the number of data bits per second. Where our binary signal is being used, this is the same as the baud rate. When the signal is changed to another form, it will not be equal to the baud rate, as each line change can represent more than 1 bit, either 2 or 4 bits. When you say bandwidth, is the frequency range of a channel measured as the difference between the highest and the lowest frequencies that the channel supports. The maximum transmission speed is dependent upon the available bandwidth. The larger the bandwidth, the higher the transmission speed. So, data flow samples. So, only transmit in one direction, rarely used in data communications such as web TV. Receiving signals from the radio station or CAT TV. The sending station has only one transmitter. The receiving station has only one receiver. So, this is the simplex transmission, which is the mainframe direction of data to monitor. So, data flow half duplex. Data may travel in both directions, but only one direction at a time. Provides also non-simultaneous two-way communication. Computers use control signals to negotiate when to send and when to receive. The time it takes to switch between sending and receiving is called turnaround time. So this is the station between. This is the both station from direction of data at one at a time. So this is example of half duplex transmission mode. So data flow full duplex. So when you say full duplex, it is complete two-way simultaneous transmission, faster than half duplex communication because no turnaround time is needed. So This is also a station from station to direction of data all the time. This is the use of full duplex mode.